Hello students, welcome to CS Academy. In this session, we will discuss the next topic in centrifugal pumps, that is heads and efficiencies. Heads and efficiencies of centrifugal pump. Okay, it is very important in all competitive exams for AWE and all APPSC exams. Okay, please listen carefully here. And if you see the centrifugal pump diagram, let's consider there is a impeller. Let's consider there is an impeller like this, and impeller has vanes like a backward. Impeller has vanes like backward like this. Okay, as the vanes are in this direction, so the rotation of this impeller is in this direction, that is anti-clockwise rotation. Okay, as I told in the previous session in yesterday, the impeller may be like this also. That means the blades arrangement will be like this also. Based upon the blades arrangement, the rotation will take place. Okay, if you see for this impeller, the diagram will be like this. The diagram will be like this. Okay, that means the cross section of this casing should be as increasing the area. Okay, if you see here, because of this rotation is like this. Okay, the cross section will be varying like this. Okay, so here this is the inlet and this is the inlet for this section. Okay, based upon the vanes arrangement, the cross section will be varied. Okay, as I told in my first session, this cross section is varying like area is increasing from this point to this point. Okay, it will impact the velocity will be decreased and pressure will be increased. Okay, this is main intention of the centrifugal pump to increase the head or pressure. Okay, and if you see here, in this session we will discuss this heads and efficiencies. In the centrifugal pumps, there are total 4 types of heads are there. 4 types of heads are there. If you see the centrifugal pump heads, the first one is in heads, that is a suction head. Okay, suction head. We will denote this suction head as a small h suffix s, and the suction head is also called as a suction lift. Okay, suction lift. Diagrammatically, we will represent this suction head as like this. Let us consider this is the impeller. This is the impeller which is having backward curved vanes. The rotation of this impeller is like anti-clockwise direction with omega. Okay, if you see the cross section of this casing, it is increasing the cross section like this. Okay, and this is the outlet, and here there is a one eye of the impeller. At this eye of the impeller, we will get one pipe, that is a suction pipe. Here it is a sump which is having a water with atmospheric pressure. Okay, and if you see here, this is the axis of the impeller. This is the axis of the impeller. Yes or no? From this axis of the impeller to at the head of, that is the top side of the sump, the total vertical distance from the sump to center of the impeller is called suction head. Okay, suction head. This suction head is also called as suction lift. Why you are calling this suction lift means, from this point, because of this pressure difference between these 2 points, here is the atmospheric pressure. Okay, here there is a less than the atmospheric pressure. Because of these 2 pressure differences, okay, the water is entering from this sump to this center of the impeller. Okay, that is water is sucking into this impeller because of this pressure difference. Okay, the working of this centrifugal pump I told in my previous video in the first session. Please go through this video. Okay, here this is the suction head. Okay, this is the suction head, also called as suction lift. Okay, and one more head in the centrifugal pump is delivery head. We will denote this delivery head as H suffix D. Okay, and here we will see this diagrammatically here. This is the axis of the impeller. From this axis of the impeller to this outlet pipe. This is the outlet. Okay, at this outlet, from this point to center of this impeller is called delivery head. Okay, listen carefully here. This is from the sump to center of this impeller is called suction head, and this axis of the impeller to delivery point is called delivery head. These 2 are the most important things. Before going to the efficiency, we should know these heads. Actually, what is the exact meaning of head means? It is a vertical distance from one point to other point. Okay, as I told in my previous session, that is the head is directly proportional to pressure. As we are increasing the head, the pressure of this system or centrifugal pump will also increase. That is the outlet, whatever we are getting this pressure will be increased because of this head. As I told before, pressure is nothing but of rho g h. As the head is increasing, pressure is increasing. So the main intention of the centrifugal pump is to increase the head or to increase the pressure of this fluid to send from this low level to high level. Okay, these are the two most important heads in this centrifugal pump. And the other head is static head. The third one is static head. Static head. Okay, and here in this static head, we will denote this static head as a capital HS, and this static head is nothing but of the total summation of this suction head and delivery head is nothing but of static head, that is H suffix H plus H suffix D. Okay, static head is nothing but of from the sump point to at the top of the sump to at the delivery point, the total head where in the centrifugal pump is called static head. Okay, listen carefully here. The summation of static this suction head and delivery head is nothing but of static head. Okay, and the most important next head is a manometric head. Manometric head. Listen carefully. This is the very important head out of this all four heads. Okay, listen carefully here. The next one is a manometric head. We will see this manometric head in the diagrammatically. Manometric head. Okay, we will denote this manometric head as capital H suffix M. Capital H suffix M. Here if you see the word manometric here, as we saw in manometers, okay, in our manometers, let us consider a pipe. We arranged one manometer to this pipe to calculate the pressure. Yes or no? Here we are calculating the pressure of point A with the help of this manometer. Because of this pressure variation, the manometric fluid is varying the height. Yes or no? As the height is varying, we are calculating at this exact point, and the pressure at point A is nothing but a rho g h. Yes or no? Here we are calculating with the help of the head, we are calculating the pressure. Yes or no? With the help of this manometer. Similarly here, with the help of the head developed by this centrifugal pump, we will calculate the pressure developed by the centrifugal pump. Okay, like this, similar to this manometers, the definition of this manometer head is nothing but of the total head against which centrifugal pump has to work. That is, the total head developed by the centrifugal pump is nothing but a manometric head. With the help of this manometric head, we will calculate the pressure developed by the centrifugal pump. That is, the pressure developed by the centrifugal pump is nothing but a rho g H suffix M. This is the manometric head. Okay, if you see here, this is the definition here. We will calculate this manometric head into three types. The first one is, let us consider manometric head is HM. Here, manometric head is nothing but of mathematically we calculate as suction head plus delivery head plus suction head plus delivery head plus. And here, listen carefully, very important point here. To run this centrifugal pump, we are supplying externally some power. Yes or no? We are supplying externally some power. That means the total head developed by the centrifugal pump. Here there are some losses in this suction head and delivery head. Yes or no? The losses, that means here if you see, these are the losses in the suction pipe. Losses in the HF is nothing but of losses. Head losses. These are the head losses. Okay, head losses. If I give suffix S means is the losses in the suction pipe. These are the losses in the suction pipe that should be developed by the centrifugal pump only. We are not giving externally, just we are giving externally some power to this centrifugal pump to run this impeller. But the head is developed by the centrifugal pump only. Yes or no? So here the losses, whenever the water is sucking from this sump to this impeller inlet, the head should be developed by this centrifugal pump only. Yes or no? So some losses will be present in this suction pipe. That head losses also should be developed by the centrifugal pump only. That means the total head developed by this the centrifugal pump is nothing but a manometer. That manometric head is nothing but a suction head plus delivery head. Along with the suction and delivery heads, there should be some losses which should be developed by the centrifugal pump only. This is the suction head losses and these are the delivery head losses. Okay, and one more, this is the suction head losses here which is present in the suction pipe, and these are the delivery head losses which are present in this delivery pipe. And one more losses are there, those are the exit losses. There is some velocity of the fluid, some velocity of the fluid, there are also some losses, that is the exit loss. As we know, V is equal to square root of 2gh, yes or no? So if we here, this is the head losses or this exit. If we want to head, we have to square all both sides, we square by 2g. Here I am considering delivery, here I will put the d. Okay, if you see here, I will write this as Vd square by 2g. Vd square by 2g. These are the total head developed by this centrifugal pump. That is, the total head developed by the centrifugal pump is nothing but a manometric head. With the help of this manometric head, we will calculate the pressure developed by the centrifugal pump, that is rho g into hm. Okay, this is the one way of calculating this manometric head. Listen carefully, very very important. This is the manometric head. To calculate the efficiencies of the centrifugal pump, we use this manometric head. Okay, and I told this suction head and delivery head. The summation of suction and delivery head is nothing but of static head, that is H suffix capital H suffix S. Yes or no? That means this manometric head will also be written as Hm is nothing but a capital Hs plus Hfs plus Hfd plus Vd square by 2g. This is the one way of calculation of this manometric head. And there are some other methods are also there to calculate this manometric head along with this first method. And that is the manometric head we will see in the next step, that is Hm is nothing but of. Here we consider this losses in this suction pipe and delivery pipe, and some losses are also there which is present in this impeller. Yes or no? Here the total work developed, here let assume this work developed by this centrifugal pump per unit weight, work developed by the centrifugal pump per unit weight is nothing but of Vw2 E2 by G. Okay, this is let remember this one. I will explain this derivation for this work developed by this centrifugal pump in the next session. Okay, because of we have to use this formula here, that's why I am telling here. Just remember this formula. I will tell the derivation for this next in the next session. Okay, and this is the Vw2 U2 by G. Okay, Vw2 U2 by G. Just remember this formula. And if you see the manometric head, that is Vw2 U2 by G. Okay, this is the work developed by the centrifugal pump. Just remember this formula. I will tell the derivation in the next session. Okay, this is the work developed by the centrifugal pump. And here there are some losses which are present in this impeller. That losses should be subtracted from this work developed. This is also one type of one way of calculation. Okay, and this is the losses in impeller. This is the second method of calculation, this manometric head. Okay, and one more method is there which is very very important. From the Bernoulli theorem, as we know, the total headed inlet to total headed outlet is equal. But here there are some manometric head. That is, the manometric head is nothing but of Hm is equal total headed outlet minus total headed inlet. The difference between heads of the outlet and inlet is nothing but of manometric head. This is the third way of calculation the manometric head. Here how we will calculate means Hm is nothing but of, as we know Bernoulli theorem, that is P by rho g, that is the outlet is nothing but of P naught by rho g plus V naught square by 2g plus Z naught minus Pi inlet is nothing but of Pi by rho g plus Vi square by 2g plus Zi. Okay, the difference between total heads of this outlet to inlet is nothing but a manometric head. These are the three ways of calculating the manometric here. Okay, are you understand? Okay now? Are you okay now? Okay, now here in the next we will go to the efficiencies. If we understand this heads, total 4 types of heads, we will go to the next session, that is the efficiencies of this centrifugal pump. Okay, now there is one question here. Many students are getting confused during this calculation of this manometric head. Okay, during the calculation of manometric head, that is the first type, that is Hm is equal to Hs plus Hd, that is plus Hfs plus Hfd plus Vd square by 2g. Okay, many students are getting confused that whether we have to add this losses or not, whether we have to add or subtract. Many students are getting a doubt that in the questions in the question in ABPSC they are asking that the manometric head, which of the following is correct for the manometric head? They are giving options like this: Hm is equal Hf plus Hd minus Hfs minus Hfd minus Vd square by 2g. And in the next options, they will give one side plus and other side minus, like this. They are giving 4 types of options. Okay, but there is a quite difference between turbines and pumps. Okay, in turbines, we have to subtract the losses, because as the work output we are getting here, we have to subtract the losses. But in the case of pumps, we are giving input as a power, yes or no? But we are not getting any power from the centrifugal pump. We are giving input as a pump power. Okay, but in case of turbines, we are getting power as output. But here we are giving the power as input. So in case of this pumps, we are giving this power, so that we have to add the losses also. That means these losses also should be substituted by this input only. Yes or no? That means we are giving the power, the head developed by the centrifugal pump. The losses should be developed by the centrifugal pump only. That means the power consumption to develop this head losses will be substituted by the externally. That means we are substituting this energy, so that we should add this losses also. We should not subtract these losses. I hope you got this point here. Okay, let you understand here. Okay, and here the next one is efficiencies. Okay, efficiencies. I hope you got this point here. All the types of heads. Okay, all the types of heads here. And the next one is efficiencies. To understand the efficiencies, I will tell one simple trick. You no need to by heart anything. There is one simple technique here. If you follow the technique, you will easily remember these things. No need of any by heart in these formulas. Okay. And the first one is, if you see here, the first one is, as a pump requires some electrical energy as input. Yes or no? That means the first point is, we are supplying electrical energy. We are supplying electrical energy. Yes or no? That means the electric energy which we are substituting here, the electrical energy we are supplying to this centrifugal pump, okay, that electrical energy is going to rotate the shaft which is connected to this impeller. There is one shaft which is connected to this impeller. Okay, from this there is one prime mover. Okay, we are supplying this electrical energy to this prime mover. This prime mover will rotate this shaft which is connected to this impeller. Okay, first here we are supplying this electrical energy. Listen carefully. This is very important. If you know this sequence, you can easily get the efficiencies formulas. There is no need of any by hearting here. Okay, here we are supplying this electrical energy. This electrical energy is given to this prime mover. This prime mover is rotating this shaft. This is the shaft. Okay, and here there is one shaft power. Okay, that shaft power is nothing but of here electrical energy supplied to the shaft. Okay, that shaft is rotating. Yes or no? The shaft is rotating means, as we know, the power developed by this shaft is nothing but of P is equal to 2 pi nt by 60. Yes or no? 2 pi nt by 60. Here is the torque of the shaft and the speed of the shaft. Okay, and first we are giving this electrical energy to the shaft. The shaft is rotating, and this shaft is making the rotation of this impeller. It means impeller rotation taking place. Once we are giving electrical energy to this prime mover, this is rotating the shaft, and the shaft is making rotation of this impeller, and impeller is developing this head. That is nothing but of pressure head. That is nothing but of water energy. Okay, these are the sequences in the centrifugal pump. First we are giving electrical energy, and this electrical energy is rotating the shaft, and shaft is making the rotation of impeller, and impeller giving us the head of this water. That is the pressure energy. Okay, if you see here, this is the prime mover which is consuming this electrical energy, and it is giving to shaft, and the shaft is rotating, and the shaft is making the rotation of this impeller, and impeller is giving us the water energy. Okay, these are the 4 sequences in this centrifugal pump. If you remember these things, we can easily get the efficiencies here. Here I am telling the explanation. You don't need to by heart anything, these things. First we are giving electrical energy, that is shaft, and shaft is rotating with the power of that P is nothing but of shaft power SP. Shaft power is nothing but of 2 pi nt by 60, and it is giving energy to this impeller. As the shaft is rotating, at the one end of this shaft which is connected to electrical energy, that is the prime mover, and other end of the shaft is connected to impeller. One end of the shaft is connected to prime mover, another end is connected to impeller. As the shaft is rotating, impeller is also rotating. Okay, as I told, impeller rotation is nothing but of work developed by the impeller. As I told in the previous minutes, the work developed by the impeller is nothing but of VW2 U2 by G. Okay, just remember this formula. I will explain this derivation in the next session. Okay, no need to by heart anything. Just remember for this session. Okay, and this is the work developed by the impeller. That is the work developed by centrifugal pump. And finally, because of this rotation of the centrifugal pump, this is the impeller, it is giving some head to this outlet. Okay, that head is nothing but of water energy or pressure energy. Okay, this is the sequence. Just Just remember this sequence. Now we will do this efficiency of the centrifugal pumps. Okay, and if you see the efficiency of the centrifugal pump, there are three types of efficiencies are there. Three types of efficiency are there. First one is the manometric efficiency, second one is the mechanical efficiency, and third one is the overall efficiency. These are the three types of efficiency in the present in the centrifugal pump. And first one we will see this manometric efficiency. Manometric efficiency. Okay, manometric efficiency. We will denote this one as efficiency manometric, efficiency MAN. Okay, here if you see many each and everyone knows that efficiency is nothing but of output by input. Yes or no? Everyone knows this one. Everyone knows. Yes or no? If you see here, manometric efficiency, as I told, the manometric is nothing but of the head developed by the centrifugal pump. Where we are getting the head here, out of these four sequences, where we are getting head here? This is the head. This is the output. Yes or no? This is the output. That is, the head is nothing but a manometric head HM. Okay, this is the manometric head. As we are getting this manometric efficiency here, output by input. Output is nothing but a manometric head. What is the input here? This is the impeller work. Impeller work is nothing but input here. Okay, if you see the efficiency, that is output by input. Output by input. Output is nothing but a manometric head. Output is nothing but a manometric head. And input is nothing but of impeller work. Impeller work. That is nothing but of VW2 U2 by G. Okay, VW2 U2 by G. Here if we go, if you send this G to numerator, that is G HM H suffix M by VW2 U2. This is the manometric efficiency. That's it. No need of byhearting here. Yes or no? This is the sequence here. This is the manometric efficiency. Manometric is nothing but of, this is the head. This is the head, manometric head. Where we are getting manometric head? Here we are getting manometric head. This is the output. As it is the output, where is the input? This is the input. Output by input. Output is nothing but a manometric head. Input is nothing but a impeller work. That is VW2 by G. Okay, so as we send this G to the numerator, that is G HM by VW2 U2. This is the manometric efficiency. Yes or no? I think you got this point here. There is no need of byhearting here anything. Okay, if you have any doubt, please comment in the comment box. I will tell in the next session also. Okay, no need to byheart anything. This is the sequence. If you remember this sequence, there is no need to byheart anything. This is also I explained here clearly without any byhearting. Okay, this is the first one, this manometric efficiency, and the second one is that is a mechanical efficiency. Mechanical efficiency. Listen carefully. The second one, that is the mechanical efficiency. Mechanical efficiency. That is the, we will denote with M. As manometric efficiency, we will denote with MAN, efficiency man. And here mechanical efficiency nothing but of efficiency M. Don't confuse. In the questions they will give directly as the efficiency direct like this 0.8. Efficiency man is nothing but of 0.9. Like this they will give. Man is nothing but a manometric efficiency. M means mechanical efficiency. Don't get confused here. Okay. And I am explaining each and every point as related to exam. Okay. I hope you are getting these points here without any confuse. This is the second one, mechanical efficiency. As I told, efficiency is nothing but output by input. Here the word mechanical efficiency is nothing but of the efficiency of the mechanical components. Listen carefully. Mechanical efficiency is nothing but of efficiency of the mechanical components. Where are mechanical components here? This is the shaft is mechanical component, and impeller also mechanical component. Yes or no? Yes or no? This is the impeller which is rotating. Rotating parts are mechanical parts only. Yes or no? But what we are getting outside. Here we are getting mechanical efficiency. As I told, output by input. As the mechanical parts are rotating, we are getting output as impeller work. That is output as impeller work to, what is the input here? Shaft power. Shaft power is the input power. Okay, listen carefully. I think you got the point here. Mechanical efficiency is nothing but of efficiency that is given by mechanical parts. Efficiency of the mechanical parts is nothing but of mechanical efficiency here. These are the mechanical parts. This is the output, this is the input. As we are moving from this left to right direction, the right side part is the output part, left side part is the input part. This is the input and this is the output. For this, this is the output, this is the input. For this, this is the output, this is input. So similarly here, mechanical parts here, the impeller is work is nothing but of output and shaft power is the input. If you see impeller work is nothing but of VW2 U2 by G by shaft power is nothing but of SP, that is nothing but of 2 pi NT by 60. This is mechanical efficiency. That's it. Nothing is there. Okay, I hope you got the point here. This is the mechanical efficiency. Up to here we studied this manometric efficiency and mechanical efficiency. One more efficiency is there, that is the overall efficiency. Overall efficiency we will denote with efficiency O, efficiency naught. That is, overall efficiency is nothing but of the product of mechanical efficiency and manometric efficiency. The product of mechanical efficiency and manometric efficiency is nothing but of overall efficiency. Okay, if you see the product here, as we know, the manometric efficiency is nothing but of G Hm by Vw2 U2. Yes or no? G Hm by Vw2 U2. And this is the manometric efficiency, and mechanical efficiency is nothing but of Vw2 U2 by G into which one? Shaft power. Okay, if you see here, Vw2 get cancelled, U2 get cancelled, G get cancelled. That is manometric head by shaft power. If you see here, this is a manometric head by shaft power. Yes or no? That is, as efficiency is nothing but of output by input. That is output by input here. Here if you see, this is the manometric head per shaft power. This is manometric head is nothing but of output, that is this one. Okay, this is the shaft power is input, that is this one. That means this total, if we give this efficiency for this total parts of this centrifugal pump, that is nothing but of overall efficiency. Yes or no? If you see here, overall we are calculating the efficiency. For overall, the output is manometric head, input is shaft power. Overall, that means overall of this centrifugal pump, the total output of this overall centrifugal pump is nothing but of manometric head, and overall the input is nothing but of shaft power. We will not consider this electrical energy, just we are giving this electrical energy. As the definition of centrifugal pump is, it is converting this mechanical energy into this fluid energy or pressure energy. Yes or no? This is the mechanical one, this is the fluid energy. Yes or no? This mechanical energy is converted into fluid energy. We are not considering this electrical energy here. Okay, that means if you want to calculate this overall efficiency, overall output by overall input. Overall output is nothing but of manometric head, overall input is nothing but of shaft power. That's it only. Okay, these are the three types of efficiencies in this centrifugal pumps. I hope you got this heads, different types of heads and different types of efficiency of the centrifugal pumps. Okay, and in the next session we will discuss what is the relation between the Q and D, what is relation between Q and N, what is relation between Q and area. Okay, all these things we will discuss in the next session. These are the very important topic in the centrifugal pumps for all APPSC and all other exams also. Okay, and please go through these previous videos also. Please follow my next coming videos also, and please subscribe my CS Academy channel. And thank you for watching. Please subscribe the channel. Please like the videos. Thank you. Thanks a lot.